surface area of prisms and cylinders, as well as exercise 1F, which is on surface area of pyramids and cones. So we have to do 2 exercises today so that we can finish by Friday, okay? Alright, so we're going to enlarge the screen, and surface area of cylinders were taught last year, so if you forgot, this will be a good revision. Okay, so as you can see, a cylinder can be separated into 2 parts, the rectangle and the 2 circles. Okay, so we're going to write 2 lots of the area of the circle plus the area of the rectangle. And this formula needs to be known to you. You need to memorize it for the test. We will not be providing that formula in the test, so make sure you memorize them. So 2 times the area of circle is pi r squared, and the other one is, now the rectangle, because the circumference of the circle becomes the length, so we get 2 pi r h. That's the area of the rectangle. Well, this part is also known as the curved surface area. So when the question say find the curved surface area, that's what they refer to. Okay, curved surface area. And these 2 are flat. So if they say find a curved surface area, it means they just want the rectangular part. Okay, we'll do an example on that. So we'll do 2 examples, one on just a surface area of cylinder, and then the other one is a composite solid. Okay, so we start with this one. This one, a diameter was given, so you need to change that to radius, which is 6 divided by 2, which is 3. Okay, after we got that, then you have to use the surface area formula. Surface area is 2 pi r squared plus 2 pi r h equals to 2 pi times 3 squared plus 2 pi times 3 times the h. This is your h, 11.3. Round to 2 decimal places, so you don't need to write your answer in terms of pi. All you have to do is just press, do the buttons. So 2 shift pi times 3 squared, and then plus 2 shift pi times 3 times 11.3. Good. All right. So we got that. Okay, so we write it down correct to 2 decimal places. So 269, 269.2 decimal place, 55. Any question? That will be square meters because this is an area. Okay, done. Question? Yep. All right. After we do this, we'll do the second one. The second one is a composite solid. So you need to be careful. When it comes to a composite solid, you do not include the surface that is inside. So see this part here, we do not count that area. Okay, because it's covered. So if you try to paint this, you can't paint it because it's inside. So we can't count this area. So that means we need to be flexible with this formula because no longer we have to include that area of the cylinder. Okay, so what you do is this. We have to find the area of each. So what you do is, let's start with the rectangle because the rectangular prisms are easier to do. This is like a square prism because that's 20 as well. So we find the area of the base. So let's do that. So I rub this off. So right, surface area. So you get the base, which is 20 by 20, right? And then you have this, the other faces, which I'm going to do in red. So you see these ones, right? This one, and there's 4 of them, and they're all the same. So you just go 10 times 20 times 4, because there are 4 of them. They're exactly the same. And then we're going to continue. Now we've got these faces, and then the next face we're going to add will be, let me see, I've used up the green. Maybe I use this one. Okay. All right, this one, which is the curve bit, right? So we add the curve bit, and the curve bit is the formula for the curve bit is 2 pi RH. 2 pi RH. So the H is the 8, and the radius is 6, right? This is the R. This is 6. So you go plus 2 pi times 6 times 8, right? That's the curve bit. the curve. Okay. All right. We're not finished yet. We got one more. The last one, maybe I use another color, green. Okay. Can you see? If I paint this one and the bottom one, if we add them together, so if I draw the top view, it just becomes a rectangle, isn't it? So you don't have to calculate the area of the circle. You just find the area of the whole rectangle, which is 20 by 20. Get the idea? So you don't need the area of the circle. It's part of the. It's inside the whole rectangle or the square. So that's the final answer. So you don't have to find the green bit and the bottom bit separately. You can add them together, which becomes a rectangle. Okay. All right. Let's see whether it's right. So we're going to type this on a calculator. So 20 by 20, and there's two of them, plus 20 times 400, no 40, plus 2 pi r times h. Yes, hopefully everyone got that, which is equal to, in blue, equal to 1901.59 square centimeters. That's the surface area of this composite solid. So composite shape can be a little bit more difficult, so make sure you look at it very carefully. All right? All right, good. Well done, that's good. Now we need to do one more exercise, which is the next one, surface area of pyramids and cones. So that's new to you. Surface area of cone is new, so we need to develop a new formula. Okay? All right, I'll leave that on for... Now over there, can you please close your laptop? Adrian. Thank you. Press record. Okay. We're going to develop a formula for the surface area of a cone. Now, on this whole page, we'll develop the formula. Okay? And once we develop, you just have to memorize the formula. So the formula is a bit tricky. Let's see why this is tricky. Now, if you look at the cone, it has two parts, the circle and this bit here, isn't it? That if you take this, if you join these sides together, you get the cone, right? So if you ever made a party hat, you will see one of the net looks like this. So if you join these two edges together, you get the cone. And the question is, what's the formula to calculate that area? So we're going to develop the formula today. So let's start reviewing the area of a sector. Okay, area of the sector. So if you did your homework, you would have done some question on that. But the question is, we don't have an angle. So if I have an angle, that would have been very easy, isn't it? That would have been theta over 360 times 2 pi, not 2 pi, pi r squared. See, the problem with the cone is that we don't get to calculate this angle, isn't it? It's hard to calculate. So what you're going to do is to, we can't use the formula. We're still going to use this, but we're going to adjust that a little bit. We're going to replace that by fraction. If we can work out the fraction of the full circle, then we can calculate. So the question is, how do I get the fraction of the circle? So what we're going to do is, we're going to find the total circumference. Total circumference. 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 Okay, so the total circumference is 2 pi r, isn't it? Which is easy, 10 pi. And then to get the fraction, we just have to go 20 out of 10 pi, isn't it? Right? 20 out of the total circumference to get our fraction. So if you simplify that, let's do it on a calculator. So that tells you that if I go 20 divided by 10, actually doing the fraction, sorry. Fraction 10 pi, press equal, it gets this number, 0.63 or 0.64, about 64% of the circle, isn't it? Can you see I could get the percentage of the circle by dividing by the length of this arc, 20, by the total circumference, which is 2 pi r. Okay, why do we use the 20? Because on the cone, I could work out the circumference of the bottom circle. That's why I could work out this. So let's develop a formula for that. So we're going to find the surface area. Why is it a bit different from the old version? Okay, so all we do is this. We're going to start with, okay, so as you can see, the cone consists of the circle and the top bit, which is a sector when you unfold it. So the area of the circle is, the radius of the circle is r, because of that r here. But the radius of the big sector is L. Can you see that L is this length? The L has a special name. Raise your hand if you can tell me what that name is. There's a special name for that. Anyone know? It's called the slant height, because it's not straight. It's not perpendicular to the base. It's called the slant height. And of course, if you draw a cone, this height is called the perpendicular height. So there's two heights here: perpendicular height and the slant height. Now, when it comes to the surface area of the cone, it is the slant height we're going to use, because the slant height is the radius of the big sector. Okay, so we've got the L, we've got the R. Okay, but we know that let me use a red pen. Can you see this circumference at the bottom must wrap around this bit, isn't it? Can you see that? Because when you join this edge, it becomes this bit. So these two lengths must be the same. They are circumference of the circle, which is the 2 pi r, right? 2 pi r. Right? If you join this to the bottom circle, they will join, right? The red bit. So this is 2 pi r. All right. Any question? This is very important. Okay, let's develop. Now we're going to find the area of this. So to find the area of that, we're going to label, this is 2 pi r first. And remember, the radius of the circle of the sector is L, the slant height. We're going to calculate the fraction of the full circle. And the fraction will be, which is the arc length, which is this is the arc length, over the total circumference. First. Okay, total circumference. All right, this is in the way, so I'll write it over there. All right, okay, this length here is the slant height. Okay, so the arc length we just found is 2 pi r, isn't it? Because it's same as the radius circumference of the circle at the bottom. So write 2 pi r on the top. What is the circumference of the full circle? So if I were to draw this full circle, what's the circumference of the full circle? It will just be 2 pi L, isn't it? Right? 2 pi L will be the full circle. 2 pi R is this circle. So there's two circles. This circle and the big one. Okay? So be careful. So I'm just writing in red. The red bit is, oops, let me choose the right color. The red bit is 2 pi R, right? This is just this bit. How do I get 2 pi r? Because this just joins this circle, isn't it? The red bit joins this circle at the bottom. Yes? That's why it's 2 pi r. Whereas the 2 pi L is the big circle. By dividing by the arc length by the total circumference, we get the fraction of the whole circle. Like we did here. We did 20 divided by the total circumference. We got 64%. Now, as you can see, they cancel out. What gets cancelled out? The 2 pi. So you end up with r over L. That's the fraction. So we have a simple formula to calculate the fraction of the full circle. Just divide the radius by L. Very, very convenient. Now we can write down the surface area. Okay? R over L. Okay. So now to find the area of the sector, let me draw this again. Right, L. So area of sector equal to fraction. We don't have the angle, just the fraction times pi L square, because that's the area, pi L square. And the fraction we got from our working out was R over L. So we're going to use this R over L times pi L square. And we see that there's another cancellation we can make. With this time, which one can we cancel? Anything we can cancel? Yep, Jaden. The L, but not all of it. There's one L here, but there's a square, so you only got one out. So the formula for that area is simply pi RL. So you have to memorize that. Pi RL is the area of this. So now we have a final formula. Pi RL. So area of this, that's called the curved surface area, which is pi RL plus pi R square. Done. That's the surface area. Any question? Okay. So pi RL is the curved surface area. Pi R square is the area of the bottom. Okay, remember L is the slant height. We have to do 4 more examples, then we can start the exercise. Okay? Alright, let's do it. Let's go to the next page. I will leave it on just before I move on. Okay. We're going to use this example. Find the surface area of these solids. Okay. Now, cone with a radius of 2 millimeters and height of 4.5. Oh, that's a slant height. Okay, easy. L, R, right? Find the surface area. Pi R square plus 2 pi, plus pi RL. Pi RL. Very easy. So you just go pi times 2 square plus pi times 2 times 4.5. Now, if the question wanted to leave it in terms of pi, you can just go like this. 4 pi plus, this is 9 pi, so it's 13 pi, isn't it? So if they wanted to be exact, but if they wanted to be in 2 decimal places, you just have to press the button on the calculator. Do 13 pi equal 40.84 millimeters. Any question? Yep. All right. Pyramid will be even easier to do. You don't have to use a formula, because for a pyramid, you just find the area of the triangles, right? Because there's no curve bit. So this is a square pyramid, so all the triangles have the same area. So let's find the area of one triangle, which is half times base, which is 25, times 22 height. So I'm just writing the formula, B times H times half. And because there are 4 triangles, we have to times by 4, right? 4 triangles. And then you have to plus the area of a square at the bottom. So you go 25 square. And then you just press all of these on a calculator. So we just go 2 times 25 times 22 plus 25 square equal 1725. That will be the area of the pyramid. Okay, pyramid is a bit easier. You just have to find the area of the triangle and the square base. Okay, very easy. Alright, let's look at the next one. Now, before I move on, just be careful. Not all pyramids are square pyramid. Sometimes you have a rectangular base pyramid, in which case you have to split the triangle into 2. So there's 2 different types of triangle. Just be careful, okay? So there will be some question like that in the exercise. Make sure you are aware of that. Okay, so we're going to move on. Example 2 on a cone. A cone have radius 3. Let's draw it. Radius 3. Have a curved surface area of 100. So that means this bit here is 300 is 100. So if I cut this into a net, right, this means this is 100, right, square centimeters. Now they ask you to find the slant height. Well, slant height is just L, isn't it? Right? And we can find L by using the formula for the surface area of the cone. I keep saying 2. It's pi RL, right? That's the curve B. And that equals to 100. Now, how do I find the slant height? Now, because I have the radius, I could work out L, isn't it? So, pi times 3 times L equal to 100. So how do we solve for L? We divide 3 pi. And then you have to correct to 1 decimal place. So we write fraction 100 over 3 pi. And you get 10.61 is the answer. 10.61 square centimeter. Just length, cm. Okay. Right, question. Pretty easy, because after we got that, we have to find the height of the cone. When they say height without the slant height, it's automatically assumed to be the perpendicular height. So whenever it's perpendicular height, we don't have to say it, we just say height. Only when we say slant height is the slant height. If I just say height, it is always the perpendicular height. Okay, we're going to find the perpendicular height. So we're going to label that as H for height. And the radius is still 3. And we're going to use a rule to work out the height. Now we know the slant height to be 10.61. So let's write 10.61. That's the slant height. Using Pythagoras, I could work out H. So write H squared equal to 10.61 square minus 3 square. To make it easy, I just go like this, square root. Right, that gives me my answer. So press the button on the calculator, square root 10.61 square minus 3 square equal 10.18. Correct to 1 decimal place. So 10.2, okay? 10.2 cm. Alright, so we've done some hard question and the easy question, as well as developed the formula for the surface area of a cone and the surface area of a cylinder. Make sure you memorize these formulas and do the 2 exercises today. Now, don't start yet. Hang on, let me just finish. Hang on, excuse me. I need to